section 5.2, which is called Functions, Rules, and Tables and Graphs. In this section, function, rule, and table and graphs, they are all related. And what we're going to do is we're going to model functions using the rules, which is an equation. So function rules are equations, and we're going to turn that equation into a table, and then we're going to graph it. But a couple words that we need to know for this section is continuous data. And these are data that are collected or used that are represented by numbers that are either fractions or decimals. So it consists of numbers between whole numbers. So when you graph this, you do connect your points together when you graph this table. In a discrete data, these numbers are whole numbers, and we do not connect these data points when we're dealing with discrete data. So like number of people or number of CDs, anything like that that has to use whole numbers for your data is called a discrete data. So in example number 1 today, we are going to model the function rule, which is y equals 1/3 x plus 2. And using the data, we're going to create a table of values, and we're going to graph. So the numbers I want you to pick for this particular type of problem are going to be most of the time -2, -1, 0, 1, and 2. But because this is a fraction, we're going to change it up a little bit, and we're going to use the multiples of the denominator. So since the denominator is 1/3, here's x. Here's 1/3 x plus 2, and that's the result of that will be giving me a y value. So what we want to do is we're going to use the multiples of 3. So instead of -2, we're going to use -3, and then we're going to use -1, 0, 1, and 3. Now I wanted to use 1 and -1 because I want to show you how to plot fractions. So to evaluate this, we plug it in for x, which is -3, and I'm going to make that -3/1 because this is a fraction. So -1/3 times -3 becomes -1, and -1 plus 2 is 1. And the next number, 1/3 times -1. And 1/3 times -1 gives me -1/3, and -1/3 plus 2 is 1 2/3. And then 1/3 times 0 plus 2, this is 0. 0 plus 2 is 2. And then 1/3 times 1 is 1/3 plus 2. And 1/3 plus 2 is 2 1/3. And the last one is 1/3 times 3, which is 3/1. And plus 2, this becomes 1. 1 plus 2 is 3. So once we have our values, we're going to plot these points. And what we're going to do is we're going to create an order pair using those points. So you got -3, 1, -3, 1. And we got -1, 1 2/3. And then you got 0, 2, and 1 2 1/3. And we got 3 3. So we're going to use those ordered pairs to graph this function rule. So we're going to create our x and y axis. So this is our y axis, here's our x axis. So here's our y, here's our x. And then if you go on this side of the origin, you got 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, -5, 1, 2, 3, 4, 5, -5, and 1, 2, 3, 4, 5. So we're going to start with -3, 1. So you go -3, 1. And next point is -1. And -1, and it's 1 2/3. So what we're going to do is we're going to go from 1 to 2, and you're going to divide that into 3 sections. So here's 1/3, here's 2/3. So -1 and 2/3 is right here. And then 0, 2. And we got 1 and 2 1/3. So here's 1/3, here's 2/3. So 2 1/3 is right here. And the last point is 3, 3. And whenever we graph a function rule, we are going to connect the dots, and this creates a line, which the line goes on forever, and we make an arrow at the end of the lines. And this is how you graph a function rule using a table. In example number 2, we are going to take a word problem. And this word problem says, at a local video store, you can rent video games for $3 each. And for $5 a month, you can rent video game operators, like your consoles, so the cost, which is C of V, this is a cost that depends on the V, which is that depends on number of video games, which is V. So cost, which depends on number of video games, V, is given by the function rule C of V equals, now remember, it's $5 a month plus $3 per video game. So this is the function we're going to use to make a table and graph. So, but let's talk about what kind of data points we're going to use. So this is the number of video games. Number of video games, because we can't rent a half a video game, we are going to have to use the discrete data. These are considered discrete data. So we're going to use discrete data because this is data that uses the whole numbers, and you can't use part of a fraction or decimals in this. So we're going to use discrete data. So the numbers you pick, and because it's the video games, you can't rent negative videos, so we're going to start with 0. So we're going to use 0, 1, 2, 3. And the function rule is 5 plus 3v, and that will give me my cost of the videos. So when you plug it in, 5 plus 3 times 0, 3 times 0 is 0, plus 5 is 5. So no matter if you rent 0 videos, you still have to pay for the operator. And the next one is 5 plus 3 times 1. 3 times 1 is 3, plus 5 is 8, so you pay $8 to play one video game. And then 5 plus 3 times 2. 3 times 2 is 6. 6 plus 5 is $11. And then 5 plus 3 times 3, which is 9. 9 plus 5 is $14. So on and so on. So we are to graph this, but because this is a discrete data and we can't rent negative videos and we don't have negative cost, we're just going to graph the first quadrant of our Cartesian graph. So this side will represent our cost of the videos, the rental, and then this will be the number of videos. So we're going to start at 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and we're going to go up by 2's on this side. So 2, 4, 6, 8, 10, 12, 14, and so on. So we're going to plot these points. So at $0 video games, it cost me $5. At 1, it is 8. And at 2, it's 11. And then at 3, it's 14. And because this is a discrete data, we don't rent anything between 0 and 1, 1 and 2. We do not connect the data points, and we just draw an arrow because it does go on forever. Now the next example, we'll be graphing different types of functions, in which you have to know how to do. So in example number 4, I want you to graph y equals absolute value of x plus 2. Remember, absolute value of x means how far is a number away from 0. But absolute value functions, this is called an absolute value function, whenever you see absolute value of x positive absolute value of x, it will always be an upright V. Now if there's a negative on the outside of the absolute value, it will be an upside down V. Because this is a positive, this is going to be upright. So now we're going to still create a table. So, and then this is absolute value of x plus 2, and we're going to get a y values. And so remember, the numbers that I like for you to use are -2, -1, 0, 1, 2, unless there's a fraction. And then we want to do the multiples of the denominator. So you plug it in, absolute value of -2 plus 2. Well, absolute value of -2, -2 is 2 units away from 0, so this is 2, 2 plus 2 is 4. This one, absolute value of -1. Absolute value of -1 is 1, 1 plus 2 is 3. Absolute value of 0 plus 2, absolute value of 0 is 0, plus 2 is 2. And then absolute value of 1 is also 1 units away from 0, so 1 plus 2 is 3, and absolute value of 2 is 2, 2 plus 2 is 4. So now when we graph this, you can see there's a y-axis, x-axis. Here's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, -5, 1, 2, -2, 1, 2, 3, 4, 5. Now we're going to plot those points, -2, 4. So -2, 4 is here. -1, 3, 0, 2, 1, 3, 2, 4. And you can see that this creates that V shape that we talked about for absolute value functions right here. So remember, when it's an absolute value, the graph should be a V shape. The last thing we're going to graph is y equals x squared plus 2. And because this is an x squared, all x squares makes a U shape. And then negative x squared, because there's a negative on the outside of the x squared, it makes a upside down U. So you have to remember this, graphing anything with x squared in it. So we're going to create a table again. And we're going to use the same points for x. -2, -1, and then we got 0, 1, and 2. But in this one, I am going to add -1/2 and +1/2 as one of our other points to show you that this makes a U shape instead of a V. So now when we plug it in, I got x squared plus 2, and this being our y value over here. Now you plug it in, -2, but remember you plug it inside the parentheses, -2 squared plus 2. -2 is 4, 4 plus 2 is 6. And then when you put -1 squared plus 2, -1 squared is 1, 1 plus 2 is 3. Now here's the fun part. I'm going to plug in -1/2 inside a square plus 2. In this one, when you square numbers like this, a fraction, you square the top and you square the bottom. So -1 squared is 1, over 2 squared is 4, so it's 1/4 plus 2, and 1/4 plus 2 is 2 and 1/4. And we do the same thing, 0 squared is 0, plus 2 is 2. And then we do it again, 1/2 squared plus 2, 1/2 squared is 1/4, 1/4 plus 2 is 2 and 1/4. And then 1 squared plus 2, 1 squared is 1 plus 2 is 3, and then 2 squared plus 2, 2 squared is 4, 4 plus 2 is 6. So now we have our points, and we want to graph this. And you will see why this makes a U shape. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. -5 in that direction. 1, 2, 3, 4, 5. -5 and 1, 2, 3, 4, 5 in this direction. Okay, and we're going to go all the way up to 6 in this one. So the first number is negative 2, 6. So negative 2, 6 is here. Negative 1, 3 is here. And then here's 3. And then after that, we got negative 1.5. Negative half is right there. And it's going to go up to 2 and 1/4. So here's 2. We're going to divide this into 4 parts. So here's 2 and 1/4 right there. And then add 0, 2. And then 1/2, this is negative 1/2, this is positive 1/2. 1/2 is 2 and 1/4 also. And then at 1 is 3, and then 2 is 6. So if you notice right here, it makes that rounded bottom, which makes that U shape. So x squares always has to be a U shape and make it a round at the bottom, because when you do your fractions near that number, it will give you that rounded shape. And this shape is called parabola, which is a graph of a x squared function, which is called a quadratic.